Hey there everyone, Mike back here with you with the latest in our Weather You Want to Know series. We'll be talking about local winter weather climatology across the Mid-Atlantic region, and we'll be getting into some teleconnection material as well. So let's go ahead and get started. Take a look at some topics here for our series. First, we'll be talking about some winter weather climatology, and we'll be talking about a recap of last winter. All of the climate statistics here you're going to see are courtesy of our climate program leader and climate guru in general, the great Larry Brown, forecaster here at the National Weather Service office in Wakefield, one of our senior meteorologists. Also, we'll be talking about teleconnections and its relationship to the Mid-Atlantic winter, and it's a very important part of the Mid-Atlantic winter climate forecast, although it doesn't get brought into the official outlook per se. A little bit of a review from our inaugural installment of the winter weather series when we talked about the winter weather outlook. This was issued early this fall, and we talked about the outlook that came from our colleagues at the Climate Prediction Center. Specifically, we're talking about the temperature outlook and the precipitation outlook. And recall that we said that there was an above normal or a probability of above normal temperature across our region, as well as an increased probability of below normal precipitation across our region. And that's largely a result of the ENSO, or the El Nino Southern Oscillation. We'll be doing a recap of that in just a couple of slides. But as you see here, the above normal on both the probability of winter temperatures being above normal and precipitation being below normal are generally in the leaning above category, although far southern portions of our area are in the likely above with respect to temperature. And what that means is the odds are slightly stacked towards temperatures being above normal and precipitation being below normal. We'll recap the winter across our climate sites. The three main climate sites of our area are Richmond, Virginia, Norfolk, Virginia, and Salisbury, Maryland. We'll be recapping across those three sites. And generally what you'll see for all three sites is a relatively warm winter. We had a La Nina winter last winter as well. And you'll notice that generally the month of January was our cooler and snowier month. And that was largely a result of this, which is the snow event that we had in early January of 2022, which brought a good amount of snow to central portions of our forecast area and northern portions of our forecast area, where we had anywhere from 2 to 5 inches across the Richmond metro area and portions of the lower eastern shore, and some very heavy totals to a foot or greater across the far northern portions of our area, northwest of Salisbury and northwest of Richmond. By and large, otherwise, we had a relatively uneventful winter, I guess you would say, in that we had several minor incursions of some lighter snowfall, as well as some cooler air outbreaks. But in a typical winter season, certainly you're going to have, periods where it is colder than normal, and that is typical. Even in a warmer than normal winter, you're going to have those periods where it is colder. So in Richmond, this is what the climate stats looked like. We had the third warmest December on record at Richmond, which was 48.9 degrees on average. That's the high and the low temperature average together. That was 7 degrees, a little over 7 degrees above normal during that December of 2021, and then above normal for the remainder of the winter as well. But again, that January was colder, largely as a result of that increased snowfall. Same story across Norfolk, where generally we had a above normal winter temperature-wise across the Tidewater, Hampton Roads area, and drier than normal as well. We did have this event in later January, where we had some lighter snow across central Virginia, but a 2 to 4 inch snow across western portions of the Hampton Roads area, with Southside getting into some heavier totals down into northeast North Carolina, where we had some heavier snowfall totals during the later portion of January. So by and large, we had a warmer and drier winter, except for that heavier snowfall event in later January for Hampton Roads. Into Salisbury, we had, again, that heavy snow event in the early portion of the month, but otherwise, by and large, warmer and drier across the entire winter season last winter. 7th snowiest month at Salisbury with that heavy snow that we had in January, but otherwise, the 5th warmest December on record at Salisbury for last December 2021, where otherwise warmer than normal on average and drier than normal on average. So looking at the seasonal snowfall, and this is over a 30-year period, all of our climate normals are generated over 30 years, 30 years of data. And that is WMO, or World Meteorological Organization standard, where we use 30-year periods. So the current standard we're using is 1991 data through 2020. And using all of that data put together that you're going to see in the following slides, note that all of the stations, the median values, which you see in those purple ovals, are going to be lower than the average, which is in those purple squares or rectangles. And generally what that signifies is the average is just the extremes, just factoring in all of those extremes, whereas the median value is the middle value. And that is more significant or more telling of what our mid-Atlantic winters typically are, especially in Hampton Roads, where you have some boom winters where we have very heavy snowfalls, but a majority of our winters are lower snowfall totals. Certainly, the statistics will bear that out as we go forward. But looking at that median value, 12 inches or more, a foot or more per year of snow, you really have to go into the northwestern portion of our area, far northwestern portion of our area, from Louisa County and on into Baltimore, Washington, or Sterling's area, up into Charlottesville and back into northern Virginia to get those heavier snowfall averages on a typical winter year. In the Richmond metro area, certainly you're going to see some snowier winters, certainly, but by and large, you're going to have a kind of a boom or bust situation there as well. Across Hampton Roads, south side Hampton Roads as well, and on into North Carolina, you're going to get your median values lower than 6 inches for a typical winter, which is going to tell you, as you're going to look in the statistics in a couple of slides from now, you're going to see you are going to get those winters like last one, where you have that one snow event where we do higher snowfall totals, but otherwise, by and large, very small events that move through and bring lighter snow amounts to the area. So looking at the historical variability at Richmond, very snowy 1960s as a decade. And as you can see, that seasonal snowfall by decade, on average, 24.1 inches of snow during the decade of the 1960s. So that is maybe perhaps skewing to some degree our memory of what a snowfall season looks like in the Richmond metro area. But as you look at the following years, the cascading years over that 30-year period that we were talking about in the previous slide, that 30-year period, you'll notice that when the 60s get factored out, and in this 1971 to 2000 data, you see the 60s wind up coming out of there. Once you remove the 60s from that sample, they come lower and lower and lower. And those seasonal snowfalls have lowered over the past several decades. The least snowy decades, 1920s, the 1990s, the early 2000s, the past couple of decades, where we've gone from 7.5 to 8.2 on average per winter season. Now you look at the past several winters across our area. This is for the Richmond area. The 1991 to 2020 normal is 8.8. The median value is 7.8. But I mean, again, look at these values: 15, 7, 12, 13, 1.5, 7.0, and then 4.7 from last year. This is the official total at the Richmond International Airport. And again, you can kind of see that boom or bust type scenario that you see at the Richmond airport, where it's a very much variable total where you see that. Now, the normal, again, is 8.8. The median value is 7.8. So basically, if you put all of our snowfalls on a map here, or on a grid here, the median value you're going to get is 7.8. That's the one in the middle. The 8.8 is basically taking the higher winters that we've had into account and averaging them against the lowest snowfall totals we've had. Then your average is going to be kind of artificially raised a little bit because you're taking the extremes into account. So the median value is a more complete expression of what a typical snowfall season in the Richmond metro area is, or in anywhere across our area. Picture is similar across Norfolk and Hampton Roads as a whole. Not as much decadal variation as we saw in Richmond. The snowiest decade was the 1910s, where we had on average 11 inches of snow during that decade, but a little bit more even at Norfolk versus Richmond. The least snowy decades, the past couple of years, actually, or the last couple of decades, really, or 1990s, the 2000s. We have had a couple of stronger or higher snowfall totals in the 2010s, where we kind of jacked that total up a little bit. So that did increase our seasonal snowfall total. But again, you look at the 30-year periods, and it's fairly well distributed, not really much noise there. But if you look at the variability at Norfolk, not as stark as Richmond, but certainly something where our 1991 to 2020 normal is 6.2, our median value is 3.4. Looking at the previous winters, again, you do get that boom bust type setup where, we've had a couple of winters, that 2018, 2019, and 1920, where we had little to no snowfall across the Hampton Roads area versus, the last winter and back in 2017-18, where we had, the one snowfall event that knocks that total up a bit. So it is kind of a boom or bust type scenario with respect to our winters. Going back to La Nina, which we discussed in our first part of our series. The sea surface temperatures are below average across the central and eastern Pacific, or the equatorial Pacific Ocean, right near the equator, remain below normal through the upcoming winter, which is going to keep that La Nina in effect through the upcoming winter and into the first part of the spring. We're going to trend towards more neutral, El Nino neutral conditions as we get into the spring of 2023. Now, what that entails, again, it's a Pacific Ocean phenomenon where we have a El Nino or La Nina, a warming or cooling, respectively, of the equatorial Pacific Ocean. So the warmer values would be an El Nino, greater than 0.5 degrees Celsius would be an El Nino. Colder, less than 0.5 degrees Celsius or below normal 0.5 degrees Celsius or greater would be a colder than normal or a La Nina situation. Now, both El Nino and La Nina can produce significant short-term anomalies or changes to our weather. But generally, the rule of thumb is the stronger the ocean signal, the stronger and more predictable what the response will be. Since 1949-1950s winter, we've had 25 winter seasons featuring El Nino, 23 featuring La Nina, and 22 have been neutral. We are expecting a weak to moderate La Nina to prevail through the winter season upcoming. And again, this will be our third consecutive La Nina winter. So La Nina serves as the main driver of circulations in the winter. So more large scale patterns are going to form our weather. So we're going to be more attuned to large scale changes. So we're going to be focusing on that polar jet, and that polar jet is going to be a big determiner as to whether we are getting into some of this colder Arctic air, whether we're allowing that to get down into our region. As it dips down, we are able to get some of that colder air to push into our area, and we get colder. And we will have episodic outbreaks of cooler weather. Even in a La Nina winter, we're going to get cold. So saying we're going to be below normal or above normal for a winter season really doesn't affect the day-to-day. It's going to be on a monthly scale or on a 3-monthly scale. So that high subseasonal variability doesn't really provide a strong signal for a warmer or cooler winter for the Mid-Atlantic region. So it certainly will play into whether we have totals at the end of the winter where we're above normal or below normal. But for the day-to-day, that variability is very much going to be something that we're going to have to investigate further. And there are other tools at our disposal to do that. So teleconnections are a big piece of that, and they can help us learn more about the winter weather picture to come. The problem with the teleconnections as a whole is they're not predictable on the seasonal scale at this time. So that seasonal outlook that you see from the Climate Prediction Center that we've discussed earlier in this video and in the first part of our series, it really doesn't take teleconnections into account for that reason, because it's really just unreliable on a monthly scale. So we really have to get into breaking these things down on a week-to-week and on a monthly basis. So for the purposes of this video, we're going to talk a little bit more about the North Atlantic Oscillation, and that's going to be a big part of what plays into our winter weather and our cooler incursions, our outbreaks of cooler air. Other teleconnections of note include the Madden-Julian Oscillation, the MJO, and the Pacific Decadal Oscillation, or the PDO. We're going to include some information for those in the notes below, so you can investigate some more of that at your leisure. But for this video, we're going to be focusing on the North Atlantic Oscillation. That's a big piece of what goes into investigating our winter weather outbreaks. So the NAO is a climatic phenomenon in the North Atlantic Ocean, as the name implies. We're basically looking at the difference in atmospheric pressure in the between the Icelandic low and the Azores high. So between these, we are looking for some fluctuation with respect to our jet stream. So the circulation frequently controls the direction of the westerly winds and the storm tracks in the mid-Atlantic. In a positive phase NAO, this is going to be for our warmer weather fans. We are going to be looking for a more progressive pattern where that jet stream is going to basically block off that cooler incursions of cooler air and basically keep it locked up into eastern Canada, northern New England, and kind of keep it progressive and moving across Atlantic Canada and moving towards Greenland. In its negative phase, we get into getting that jet stream to buckle a little bit. And by doing so, we allow some of that colder air to come on down, and we basically buckle the storm track to where we get an increased probability of getting some moisture pushed into our area, in addition to having some colder air in place. So as a result of that, we also have some blocking downstream. And what this blocking downstream will do is it'll kind of kink the hose a little bit in terms of making sure that we don't really have a very progressive pattern. And this is how you get into more lingering periods of colder air, as we have blocking downstream from the western, the far western portions of the Atlantic on into the central Atlantic basin, where we kind of block that progression of colder and snowier conditions, where we kind of make sure that colder air buckles into our region. So during a positive NAO, we have below average heights over the Icelandic area. So basically, in the Iceland, Greenland region, we basically have that colder air lingering well off to our north. And as a result of that, our jet stream is basically going to buckle north of our area. So as a result, we have more southerly and southwesterly winds that keep us warmer, in a lot of cases drier, but we'll basically have above normal temperatures across much of the eastern portion of the CONUS. During a negative NAO period, we basically start to buckle that upper trough back towards land area here. So basically we have above average heights over the Atlantic region, and that buckling allows us to remain cooler or become cooler across the eastern portions of the country. So we have below average temperatures across much of the eastern portions of the country, and that buckling of the jet stream farther south across the eastern third of the country allows cold air to drain out of central Canada into our region. So for our cooler weather fans, your negative NAO allows for more blocking to set up and allows for draining of cooler air to move down from Canada into our neck of the woods. So the negative NAO is one of the better predictors for an East Coast trough, basically the dip in the jet stream that allows cooler air to filter on into our area. This dip nearly always leads to cooler than normal temperatures across our region, which again will ramp up that threat for nor'easters and other storms to bring snow to the area. However, we also have to say that we can't use this for seasonal forecasting because the NAO, we can only look at it on a week-to-week, month-to-month scale, within a month scale, and get to the point where we can't really predict to a great amount of precision what it's going to do more than a couple of weeks in advance. So it's often not the primary mode of climate variability at a given time. So while the NAO is a good predictor of getting colder than normal temperatures, and we can rely on it for that in the short term, the colder than normal temperatures are not a good predictor of a negative NAO. So basically what that means is colder than normal temperatures can come with a positive NAO. We can get cooler air to move into our area without a negative NAO pattern. So you can monitor the NAO in real time. And with this link here, we're going to have that in the notes for you. Thanks everyone for your time today. We appreciate you viewing the presentation. For more information, look at these links here. We're going to have them in the notes section for you that you can look at your leisure. The next portion of our series is going to be on mid-Atlantic storms and storm types. So check back for that for the latest of our winter weather series. Thanks very much. Have a great day.